Section 6.6 introduces a quadratic equation, and we're going to solve quadratic equations by factoring. So you may never have heard of a quadratic equation or even the word quadratic. And all quadratic means is that the equation contains a squared term, a term with a variable that is squared. So a definition is given here as a quadratic equation is one that can be written. It's very important that you understand that it can be written in the form ax squared plus bx plus c equals 0. Notice it's an equation. It's not just an expression, not just a polynomial, but it's an equation with an equal sign. The stipulations are a, b, and c are all real numbers, and a cannot equal 0. So the coefficient of the x squared term is a real number. That's really all it's saying. And the coefficient of the x term is a real number. And the constant c is a real number. And remember, real numbers are the numbers that appear anywhere on the number line. So the only other restriction is that a cannot equal 0, meaning the coefficient of the squared term is not equal to 0. Imagine what that means. Okay, if the squared term has a coefficient of 0, all right, if there's a 0 where a is in that equation, then 0x squared is 0, which means you don't have an x squared term anymore, which means you don't have a quadratic equation. You have a linear equation. So let's look at some examples of quadratic equations. Now notice the definition says a quadratic equation is one that can be written in the form ax squared plus bx plus c equals 0. Remember, it can be. It doesn't have to be written in that form in order for it to be a quadratic. It just has to be written in that form or for us to work with it the way we're going to work with it in this particular chapter. So a few examples are listed below. X squared minus 9x minus 22 equals 0. Notice it has an x squared term. 4x squared minus 28 equals negative 49. Notice the equation does have a square term in it. It's just not written in the form that's given to us in the definition. But it could be. It could be written in that form. Okay? We'll talk about that later. Then the next one, x times 2x minus 7 equals 4. That one has a square term if you multiply the x times the 2x. So the thing is, you have to envision whether or not the equation could be written in the form ax squared plus bx plus c equals 0. And all three of these are either already in that form or can be written in that form. The standard form of a quadratic equation is given by what we just saw. Ax squared plus bx plus c equals 0. This is called standard form. Every equation that you see may not be written in standard form. Okay? It may not be written. In fact, many of them will not be given to you in standard form, but you have to put them in standard form, meaning you have to have a square term, an x term, and a constant term equal to 0. Okay, as long as the a is not equal to 0. But there's a polynomial on one side equals and then 0 on the other. That is very, very, very important that you understand. In this chapter, everything we do, we need to get the equation in standard form. All of the terms on one side and a 0 on the other. Okay, so let me ask you a question. If I give you a product and say A times B equals some number like 12, okay? A times B are two variables, and multiplied together, they give you 12. What could A and B, the values of A and B, be to give you 12? Do you know for sure which A and B I'm talking about when I say A, B equals 12? Do you know for sure? No, because I could be talking about 2 times 6, negative 2 times negative 6, 3 times 4, negative 3 times negative 4, 12 times 1, 24 times 1/2. I can get 12 an infinite number of ways by multiplying. So telling you that A times B equals 12 is not giving you any information. You don't know what those two numbers are. But what if I say to you A times B equals 0? What must be true if A times B equals 0? Well, the only way you can multiply two numbers to get 0 is if one or both of the numbers are 0. Okay, so if A times B equals 0, you know for sure. You know that either A equals 0 or B equals 0. And that is the basis that we're going to use to solve our equations. We know that when we multiply any two numbers to get 0, that one of the numbers or both of the numbers has to be 0. And this concept is called the zero factor theorem. The zero factor theorem and the zero factor theorem is defined here. It's just what I finished saying. If A and B are real numbers, and if A times B equals 0, then A equals 0 or B equals 0. We are going to make use of this theorem. Even though we won't call on the name of the theorem, we're going to use that concept, and you'll see it in the next example. Now, I just told you that if two expressions are multiplied and you get 0, then either one expression is 0 or the other expression is 0, or both are zeros. So in a sense, I want you to look, remember I used A and B. I want you to look at x minus 7 as your A and x minus 2 is B. And looking at them, A times B equals 0. Well, we want to solve to find out. See, notice we're solving equations now. When you solve an equation, you're looking for a value of x. You're looking for a value of x. And let me say this, I forgot to say it earlier, that whenever you have a quadratic equation, quadratic meaning you have a square term, you're always going to expect to get two solutions. That's squared, that's x squared, means that you're going to have two solutions. Sometimes the solution ends up being the same, but you're going to look for two solutions. If the equation contains an x to the third power, and that's the highest degree, you're looking for three solutions. We won't be working with many that have 3 solutions, but we will work with some. So when you see an equation that's a quadratic, you're not solving for just one value of x, you're solving for 2. So watch what happens here. To solve this equation, we use the zero factor theorem, and we say, well, look, the only way that x minus 7 times x plus 2 can equal 0 is if x minus 7 equals 0, or if x plus 2 equals 0. Do you see what I did there? I took the a and the b, although a and b are both binomials now, and I set them equal to 0. Because I just said the only way that this product can equal 0 is if x minus 7 is 0, that means equals 0, or if x plus 2 equals 0. Then we can go and solve each individual linear equation now. If x minus 7 is 0, then I want to find out what x is. So I add 7 to each side in this equation. Notice I told you would have 2 solutions. So what do we have here? X equals 7. That's a solution. Then with the other one, we subtract 2 from each side. Simple algebra here, and we get x equals negative 2. So our 2 solutions are, I'm going to put a box around them, x equals 7 and x equals negative 2. And notice what happens if you plug a negative 2, a negative 7 into the above equation. Wherever there's an x, put a 7. Put a 7 up there. If you put a 7 in the initial equation where x minus 7, put 7 for x. And what do you get? 7 minus 7 times 7 plus 2. Plug the 7 in. 7 minus 7 times 7 plus 2 will give you 0 times 9. But isn't that 0? Yes. So 7 checks out. What about if x is negative 2? Plug negative 2 in. Negative 2 minus 7 is negative 9 times negative 2 plus 2. The negative 2 plus 2 is 0. And 0 times negative 9 is 0. So they both check out. So you can write your answers like this: x equals 7 and x equals negative 2. Or you can write x equals 7 comma negative 2. Or you can write, you can write the solution is the set of numbers that includes 7 and negative 2. Stupid pen. Negative 2. I think my screen is dirty. The set of numbers where x is negative 7. 7 and negative 2. Okay? So that's the gist of what we're going to be doing on the first several examples. The first several examples are given to you in a factored form. Notice that they're not in the form of a trinomial, they're in the form of 2 binomials multiplied. So the factoring actually has been done for you. In our next several examples, the factoring will be done for you, but then later you're going to have to factor it yourself. Okay, so let's look at this. What is my A for this particular problem? This is the A. This x minus 5 is the B. All right. So what we do, we say, well, the only way x plus 4 times x minus 5 can be 0 is if x plus 4 is 0, so we set it equal to 0, and no, we say or x minus 5 equals 0. I want you to go through the whole step of solving each linear equation, each one of these. Don't try to jump to an answer. Work it out, because many times you will make a mistake. X equals negative 4. Here we add 5. So x equals positive 5. If you plug a negative 4 in for x and multiply everything, you're going to get 0. If you plug a 5 in for x and multiply, you're going to get 0. This is only true when you have this 0 on the side, one side by itself, and everything else on the other side is factored. It only works with the 0 factor. Okay, so here's a helpful hint. The 0 factor property says that if a product is 0, I don't care what the product is a product of, I don't care what the factors are. If a product is 0, then a factor is 0. So you have to identify the factors. So if a times b equals 0, then a equals 0 or b equals 0. But look at the next one. It says if x times x plus 5 equals 0, then you got to look at the different factors. What are the factors there? X is a factor and x plus 5 is a factor. So in this case, either x equals 0 or x plus 5 equals 0. You have to look at the factors. So if x plus 7 times 2x minus 3 equals 0, then x plus 7 equals 0 or 2x minus 3 equals 0, because those are the factors. You only use this property when the product is 0. If you have something that looks like this, but then on the other side it doesn't have a 0, you cannot use the 0 factor property. You have to manipulate your problem to make it look like that. So if a times b is equal to 8, we don't know the value of a or b. That's what I was saying earlier with the 12. We don't know what a and b are if I just tell you that a times b equals 8. It could be any two numbers. We only know that it's true when you have the product 0. All right, so here are some other examples. What are the factors here? We have x minus 10 times 3x minus 1 equals 0. Since they're equal to 0, we know that x minus 10 has to be 0 or 3x minus 1 equals 0. Then we solve each one of these equations separately. So to get x by itself, we add 10 to each side, and we have x equals 10. That's one solution. Then on the other one, we add 1. Then we have 3x equals 1. But then we divide both sides by 3. So x is 1/3, which is a fraction, but it's a valid solution. Okay, so your solutions are x equal 1/3 and 10. Doesn't matter what order you put them in. So far, so good. Next, we have x minus 12 times 4x plus 3. The only way they can multiply to be 0 is if x minus 12 equals 0 or 4x plus 3 equals 0. Then we solve each equation. Add 12, x equals 12. Then over here we subtract 3, we have 4x equals negative 3. Divide by 4, divide by 4. So x equals negative 3/4. Negative 3/4. Two solutions for a quadratic equation. Two solutions. Now look at this one. We just saw an example in the little yellow box like this. What here are the factors? What are the factors? You have a factor of x. Okay? So this x is actually your a. All right? This 4x minus 3 is the b. So you actually say, well, in order for this statement to be true, then either x is 0 or 4x minus 3 equals 0. But what solving is there to do with x equals 0? You already have an answer. 0 is one of the solutions. So 0 is a solution, but the other equation you have to solve. So we add 3 to each side, and we get 4x equals 3. Then divide by 4, divide by 4. So x is 3/4, positive 3/4. So if you plug in a 0 for x, then you're going to get 0 as a product. If you plug in 3/4 for x, try it out. Plug in 3/4 wherever you have an x in the equation and multiply it. Use your calculator. You're going to get 0. Okay? Same thing with this one. Solve x times 7x minus 6 equals 0. This one means x has to be 0 or 7x minus 6 equals 0. So x minus 0 is already solved because 0, x equals a number, is a solution. So let's add 6 to the next one. So 7x equals 6. Divide by 7, divide by 7. So x equals positive 6 over 7. That's your two solutions. Now, notice this one is given to you in the form of a trinomial. And it's a quadratic equation because it has a square term. Well, guess what we're going to have to do? Your favorite thing, factor. When in doubt, factor. This particular equation is a quadratic and it is in standard form. The x squared term, the x term, and the constant term are on one side of the equation, and there's a 0 on the other side. So it's in standard form. So all we have to do to make it look like the other equations we've had is factor it. Factor it, and you get x and x. Now we want two numbers that multiply to negative 18 but add to negative 3. So it's going to have to be a negative and a positive, but a negative what? Negative 6, positive 3. Okay? And then we say, well, the only way x minus 6 times x plus 3 can equal 0 is if x minus 6 is 0 or x plus 3 equals 0. And in this case, we add 6. So x equals 6. And here we subtract 3 from each side. So x equals negative 3. So those are your two solutions. X is 6 and x is negative 3. Notice we are solving for a solution. Next example. Is it in standard form? It's a quadratic, and yes, it's in standard form because all of the terms are on one side and a 0 is on the other. So we go in and we factor. So we get x and x. We have a negative and a positive because the 48 is negative. So let's see, 48, 4 and 12. So I would think a negative 12 and a positive 4 would do it. But the only way x minus 12 times x plus 4 can be 0 is if x minus 12 is 0 or x plus 4 is 0. So let's solve. Get a positive 12. X is 12 over here. And then let's subtract 4 on the other one. So x is negative 4. If you plug those values in one at a time, you're going to see where both sides will equal 0. Okay? Now look at this one. 25x squared minus 29x equals negative 4. Now, is this one in standard form? No, it's not in standard form. Why? It's not in standard form because you don't have all of your terms, your x squared terms, and your constant terms on one side and a 0 on the other. But wouldn't it be easy to get a 0 on, say, the right side? If only we could do one thing. Add 4 to both sides. Look at, there's a negative 4 on the right hand side of the equal sign. If I move that negative 4 to the other side of the equal sign, it becomes positive 4, right? So we have 25x squared minus 29x, plus 4 equals 0. Now is it in standard form? Yes. Now let's see about factoring it. Okay, now let's look at it and see. When you first glance at it, it looks like might be a perfect square, but let's double check it. 25x squared is a square term. 4 is a square term. But when we look at 25x squared, we should see a 5x. And when we look at 4, we should see a 2. But when we multiply those and then multiply that by 2, we actually get 20x. That should be the middle term. If it was a perfect square, the middle term would be minus 20x. But it's not minus 20x. So we have to factor this. And we have to factor it using the grouping method. So let's multiply 25 times 4. So that's 100, positive 100. So I need two numbers that multiply to 100, but add to negative 29. So that's going to be a negative 25 and a negative 4. Oh, this same little spot. Okay, now let's take our trinomial and break it up into 4 terms. So we have 25x squared minus 25x minus 4x plus 4. All of that equals 0. And I spaced it out like that so that I can come back and group these two and these two and put a plus sign in between. So then now we factor out 25x and it leaves us at x minus 1. Then we factor out a negative 4 and it leaves us an x minus 1. All of that equals 0. Then we have x minus 1 times 25x minus 4 equals 0. Now we're at the point that we can start to solve the equation. All of this was prep work. All of this was factoring to get us to this point. So I know I'm going to have to move up to the right. I know that x minus 1, now I'm going to come up here. X minus 1 has to be 0, or 25x minus 4 has to be 0. I'm going to solve each equation separately. Add 1 to each side, so x is equal to 1. But this one I have to take 2 or 3 steps to solve it. Plus 4 plus 4. 25x equals 4. Then I want to divide by 25. Okay, so our x is, I've run out of space. Let me see if I can make this smaller. Give me a second. Okay, so I've reduced the size a little bit, but let's see if I can squeeze the x equals 4 over 25. So my two solutions are x equal 1 and x equals 4 over 25. Okay, let's look at the next one. Is it in standard form? No, it's not. Let's put it in standard form. 9x squared minus 24x plus 16 equals 0. Now, is this one a perfect square? Well, let's see. 9x squared is a square term because that would give us 3x there. If, let me see, and then 16 is a square term. That would be a 4. And 3x times 4 is 12x. And then that times 2 is 24x. So this is a perfect square. So we can go ahead on and factor it. And we know that this is going to be 3x, this is 4, this is 3x, this is 4, and the middle is that. All of that equals 0. Now, because they're exactly the same, 3x minus 4 times 3x minus 4, you don't have to solve it 2 times. You just say, well, you know what, 3x minus 4 equals 0. And I can go ahead on and add 4 to each side. So 3x equals 4. And then divide by 3. X equals 4/3. But x equals 4/3 for both of those equations. So you don't write 4/3 2 times. Okay? You only end up with one solution because the equation, the polynomial turned out to be a perfect square. Okay? So let's look at the steps to solving a quadratic equation. First, write the equation in standard form so that one side of the equation is 0. Then you factor the quadratic expression completely. Then you set each factor that contains a variable equal to 0. That's very important. Each factor that contains a variable, you set it equal to 0. If it doesn't contain a variable, you can't set it equal to 0. We'll talk about that later. Number 4, solve the resulting equations and then check each solution. Now let's look at x times x minus 4 equals 5. Is that in standard form? No, it's not. Standard form means x squared term must be shown as an x squared term. So ultimately what we have to do is multiply the x times x and x times 4 to get rid of those parentheses to get our x squared minus 4x. Then we can bring the 5 to the other side and it becomes minus 5. equals 0. Take a minute and see what I just did. I brought the 5 over and it became negative, but you have to multiply those terms out in order to combine all the terms to get it to look like standard form. Then and only then can you come in and factor. So I need two numbers that multiply to negative 5. So that's going to be a negative something and a positive something. So that will be a negative 5 and a positive 1. Because they multiply to negative 5 but add to negative 4. And now we have factored it. We know we can set our factors equal to 0. X minus 5 is 0, or x plus 1 is 0. Add 5. X equals 5. Here we subtract 1. X is negative 1. Those are your two solutions. Here's another one. Same kind of setup. We need to get the 6 on the left-hand side so that we have 0 on the other side. So let's multiply x times these two terms. So we get 3x squared plus 7x minus 6 equals 0. So now we have to factor 3x squared plus 7x minus 6. Well, it's not a perfect square and it doesn't have a leading coefficient of 1. There is nothing to factor out. So we have to factor by grouping. So we multiply 3 times negative 6. So that gives us a negative 18. Negative 18. I need two numbers that multiply to negative 18 but add to positive 7. That's a 9 and a negative 2. Okay, 9 and negative 2. So I'm going to rewrite the equation. I'm going to put plus 9x minus 2x minus 6 equals 0. And then I'm going to group them. And then I'm going to go and erase this stuff over here. I grouped that wrong. It's terrible. Minus 6. All right. So let's factor out let's see, a 3x. And that will leave us an x plus 3. And here if we factor out a negative 2, that will leave us an x plus 3. All of that equals 0. Then factor out the x plus 3, and we have 3x minus 2 equals 0. Okay, now I'm going to take it up to the right, so I know x plus 3 equals 0, or 3x minus 2 equals 0. Here I subtract 3. So x equals negative 3. That's one solution. Then here we add 2. So 3x is 2. Divide by 3. X is 2/3. Okay, so x is 2/3. That's a solution. And x is negative 3 is a solution. Okay, I'm missing an equals 0 on this one down here. So we have negative 5x squared plus 20x plus 60 equals 0. Well, what you don't want is to have a negative x squared term. You don't want to have a negative. So we factor out a negative 5. You're going to hear some talking in the background now because I'm in my office, and my office is inside of a classroom. So you're going to hear some background talking. I'm factoring out a negative 5, so it's going to leave us an x squared minus 4x minus 12 equals 0. Okay, so that's a 0. And this is a parentheses. Okay, so now we have the negative 5, and this can be factored into x. Let's see, minus 6 plus 2 equals 0. So do you see now where you have 3 factors, but you can't set negative 5 equal to 0 because negative 5 will never equal 0. So at this point, the negative 5 just kind of becomes a non-issue. But we take x minus 6 is 0, or x plus 2 is 0. So here we have plus 6 on each side. So x gives us, this gives us an x equals positive 6. Here we subtract 2 and get x equals negative 2. So we have two solutions, x equals 6 and x equals negative 2. If you plug them in one at a time, you will get a true statement in the original equation. This one is similar. Let's factor out a negative 3. That leaves us an x squared plus 2x minus 24 equals 0. So we have negative 3, and then this factors to x and x. I need two numbers that multiply to negative 24 but add to positive 2. So that's going to be a 6 and a 4 some kind of way. I need a positive 6, negative 4. Alright, so negative 3 can't equal 0, so we take x plus 6 has to be 0, or x minus 4 has to be 0. The solution will now be x equals negative 6 and x equals positive 4. Those are the solutions to this quadratic equation. Now, if you have equations with a degree greater than 2, meaning if you have to the 3rd degree or 4th degree, always look to see if you can factor out one of the variables. For instance, in 2x cubed minus 18x equals 0, the x to the 3rd power indicates to you that you will have 3 solutions. Just like the x to the 2nd power in any quadratic equation indicates you will have 2 solutions, x to the 3rd means you're going to have 3 solutions. So what happens with, say, 2x to the 3rd minus 18x equals 0, we factor out a 2 and an x. So a 2x comes out. That leaves us x squared minus 9 equals 0. Now, look at what you have here. You have the 2 and you have the x. Well, 2 is a factor, x is a factor, and x squared minus 9 is a factor. But you can't set 2 equal to 0. 2 will never equal 0. So you can't come in and say 2 equals 0. But let's go on and finish factoring this because x squared minus 9 is a difference of 2 squares. So let's finish factoring. That gives us x plus 3 times x minus 3. All of that equals 0. So notice now every term or every factor that has a variable in it is what you have to set equal to 0. So we have a variable here at x, then we have a variable here, and then we have a variable here. Those are the ones that you set equal to 0. So you say now, my solutions will include x equals 0. Then we'll say x plus 3 equals 0. And x minus 3 equals 0. Well, x equals 0 is already solved. There's no other solutions, no other steps you have to take to solve it. But this one, you have to subtract 3, and you get x equals negative 3. This one, you add 3. So you have x equals positive 3. So we've got x to the third power gives us 3 solutions. So you have x is 0, x is negative 3, and x is positive 3. The next one is very similar. So here we have an x to the third, so we can factor out 7x. And it leaves us an x squared minus 9 equals 0. Okay, so once again we have 7x, and then that same difference of 2 squares, x plus 3 and x minus 3. Okay, so we say that we know that x will have to be 0, x plus 3 has to be 0, or x minus 3 has to be equal to 0. So here we have subtract a 3, so x equals negative 3, and here we add a 3, so x equals positive 3. So your 3 solutions are x is 0, x is negative 3, and x is positive 3. 3 solutions for a third degree equation. This one is already factored partially. So you have a factor of x plus 3 already. So you don't bother with that one. Now you have to go and factor this thing. Okay? That's going to take a minute. So let's multiply the way we know how to do it. So we have 3 times negative 7. It's a negative 21. So we need 2 numbers that multiply to negative 21, but add to negative 20. Add to negative 20. So that's going to be, that's going to be negative 21 and positive 1. They multiply to negative 21 but add to negative 20. So notice the x plus 3 is just going to come down. The other part, let's work on the 3x squared minus 20x minus 7. So we're going to use the factoring by grouping method to rewrite the whole thing with 4 terms now. I'm going to go minus 21x plus 1x minus 7. All of this is equal to 0. So then we're going to take bring down, let your x plus 3 just kind of wait for you at the bottom. Wait for you at the bottom because we're not going to do anything with that just yet. But let's worry about the factoring part now. So let's group these. Factor out a 3x. And that leaves us an x minus 7. Then you can factor out a 1, and it leaves you x minus 7. And then we can come on down and bring out our x minus 7 and our 3x plus 1. And all of that equals 0. Okay? So now you factored it fully, and then you have 3 separate factors. So x plus 3 equals 0, or x minus 7 equals 0, or 3x plus 1 equals 0. So we subtract 3. So we got x equals negative 3. We add 7. So x equals 7. And here we subtract 1. So we have 3x equals negative 1. Then we divide by 3. X equals negative 1 third. Okay? This doesn't look like a 3. X is negative 3. X is 7, and x is negative 1/3. So that's our 3 solutions. This one, same thing. All right, so we bring the 3x minus 2. Actually, I'm going to erase it and bring the 3x minus 2 all the way to the bottom just to wait for us down there, because we're going to be doing some other things. 3x minus 2 is there waiting for us. So let's worry about the other part. To factor 2x squared minus 13x plus 15, we have to do it by grouping because there's nothing to factor out. So we have 2 times 15 gives us positive 30. You need 2 numbers that multiply to positive 30, but add to negative 13. It's a negative 10 and negative 3. So we need to break this thing up. 2x squared minus 10x minus 3x plus 15. All of that, I'm just going to hold on to the equal 0 part right now. Let's just factor it. So then we can group factor out 2x, and that leaves us x minus 5. Factor out a negative 3, and it leaves us x minus 5. Then we have x minus 5 times 2x minus 3. All of that equals 0. So we know that 3x minus 2 has to be 0. X minus 5 has to be 0, or 2x minus 3 equals 0. Here we're going to add 2. So 3x equals 2. Divide by 3, divide by 3. So x is 2/3. Ugh, I can't get this thing in here. X is 2/3. That's going to have to do. Then we're going to add 5 here. So x is 5. Then we're going to add 3. 2x equals 3. Divide by 2. Divide by 2. So x is 3/2. So we have 3/2, 2/3, and 5. I hate running out of space. All right, 3/2, 2/3, and 5 are the solutions. Okay, last couple of problems. Here you have 3x cubed minus 9x squared minus 12x. We can factor out a 3x. And that will leave us x squared minus 3x minus 4 equals 0. We're going to have three solutions because it started out with x to the third power. So then we have 3x, and then we can factor. I need two numbers that multiply to -4 but add to -3, so that's -4, +1. So x has to be 0, x minus 4 is 0, or x plus 1 is 0. Alright, so then we add 4, so x is 4. And we subtract 1, so x is -1. Solutions are x equals 0, x is 4, and x is -1. Last example for this section, factor out a 5x. We're left with x squared plus x minus 6 equals 0. Okay, x squared plus x minus 6. All right, so then we have 5x so we factor x and x, and I need two numbers multiply to -6, add to +1. That will be a +3 and a -2. So our solutions are x is 0, x plus 3 is 0, and x minus 2 is 0. So we have -3 is a solution, and x is +2. So 0, -3, and 2 are the solutions. Next section, we're going to take these and solve word problems using these concepts that we've learned.